Good evening, everyone gathered here. It's my great pleasure to welcome you all for the second day of 3 days national level virtual research development program on advanced research methodology and statistical analysis for social science organized by Department of Commerce SF, V.H.N.S.N.College, Virudhunagar. We are so thankful to the resource person Dr. S. Muthalakshmi ma'am for making yesterday's session more informative one among the participants, and the same is to be continued in today's session also by today's resource person T. Vijay Kumar sir. Now I invite one of my colleague Mr. R. Balaji sir to introduce the chief guest of today's program. Sir, please.
Good evening, Nanda. I am grateful to introduce Dr. T. Vijay Kumar sir, Assistant Professor in Department of Economics of our college. He has over 15 years of experience in teaching, research and consulting. He has successfully completed minor research project funded by UGC New Delhi. He has also been extensively involved in conducting state and national level workshop on application of statistics using SPSS and application of biostatistics using SPSS. He has acted as a resource person more than 15 programs in the field of research methodology and application of SPSS in various colleges and published 14 articles in UGC CARE journal. Pleasantly, I welcome Dr. T. Vijay Kumar sir, Assistant Professor of Department of Economics, V.H.N.S.N.College, Autonomous, Virudhunagar, to came our virtual participant lively and interactive with his presentation. Welcome, sir.
Creativity requires input, and that's what research is. So, without any delay, let me hand over the session to our resource person. Sir, please.
Thank you, ma'am. Thank you, sir. So I'm Vijay Kumar, and I am going to share my knowledge about applications of SPSS, like statistical tools using SPSS today's session. Actually, I have planned going to touch the parametric test, and mostly used by the PhD scholars for their research work. My plan of today's session is I start with t-test, independent sample t-test and a dependent sample t-test. Then I will go for one-way ANOVA and a two-way ANOVA. With the post-hoc test, and finally I'm going to end with the chi-square test. So this is my plan of action for this session. Shall we start the session? Sorry, let us start the session now. Yeah, two-way ANOVA, sorry. Yeah, the first test what we are going to see is two sample t-test. Actually, there are two types of tests are available. First one is parametric test, and second one is non-parametric test. You might be known about that. What is parametric? What is non-parametric? Parametric, we can say that the population is known population. The population is a defined population, or the population is normally distributed. We should go for the parametric test. So the t-test, ANOVA, and other things and all come under the category of parametric test. Suppose if your population is unknown population, that means that the population distribution is not normally distributed. It means we should go for non-parametric test. And for that non-parametric test, we have some other tools like man-with t-test, Kruskal-Wallis test, some other tests. So today's session, we are going to see about the parametric test. Under the parametric test, we are having t-test and ANOVA chi-square. First, I am start with the t-test. The first t-test is called a two sample t-test, or we can say that it can be said that independent sample t-test. Normally, the t-test and ANOVA are only measure the difference between the group mean values. Only measuring the mean value of the groups. That's all. Okay, here the independent sample t-test, here also we are going to compare the mean value of two group of populations. The two group of population may be there is no relationship between the two group of population. That means that there is no dependency among the population or among the variables. I will explain with some other example later. And this test have some assumption, and I have already said that this test come under the category of parametric test. So the dependent variable is now should be normally distributed, and two samples are independent of each other. The sample what we have taken is should be independent, not dependent sample. It should be an independent sample. And some other basic assumption also I have given. You just go through that. I will give the material to the organizer. They will send it to you. Then the applications area related to that, in what are all the area the t-test can be applied. The first one, social science. We know that mostly all the social science research, the peoples are using the t-test in the way like that productivity of a particular machinery and productivity of another particular machinery. So we are going to compare the productivity of the machineries. So which one is better? Which mean value is better? So in social science, in labor, industrial field and some other fields also, we are using the independent sample t-test, and human resource management also, and marketing analysis particularly. We can say that performance of salesman A and performance of salesman B. So we are going to compare the sales performance of A and B, salesman of A and B. So we can be able to find out whether there is any significant difference between salesman A and salesman B. So in marketing analysis also we can use this test. In biological science, and nowadays people are using mostly in biological science, the t-test, independent sample tests are used by the biological science peoples. In biological science also we can say that fertilizers of the particular company and its productivity, and the fertilizers of the another company and its productivity. We just measure the mean difference between the fertilizers of the company. That means that fertilizers of company A, fertilizers of company B. So in biological science also we can apply the independent sample t-test. And followed by that last one, in nowadays, even in English language teaching classes, and mostly all the English peoples are also using, English literature peoples also using these statistical analysis tools. Say for example, in English language teaching, they are going to, say for example, they are going to introduce the new teaching method for boys and girls. And they are going to compare that the mean group have any difference or not, the output of the new techniques. So in English language also we can apply the things, that independent sample t-test. So these are all some of the applications area of independent sample t-test. And before that, we are conducting any test, we should frame the hypothesis. And I hope that you maybe know about the hypothesis. Normally, there are two types of hypothesis we used to frame at the time of doing our research. The first one is null hypothesis, that insists as that that consists of there is no significant relationship, and alternative hypothesis consists of there is a significant relationship. This is the basic things we used to frame before conducting the every test, isn't it? And this is the basic things before applying the independent sample t-test. Now let me explain some of the some two examples with the help of SPSS, how we can apply, how we can do that. And one more important thing I like to say that before applying the test, why we can apply the test, the question we should keep it in our mind. Then what is the purpose, how we can apply the test, and how we can get the interpretation, or how we can write the interpretation from the test. These three things we should be keep it in our mind before applying any test. And before applying the test also, the scholars must be known about what type of variable we are going to take, what type of variable we are going to input the data, input for our analysis. We must know about what is variable, what is dependent variable, what is independent variable, what is categorical variable. I hope that you might be clearly understand that yesterday's session, ma'am's told that about the variables and categorical types of variables also she clearly explained. So this is the basic conditions for all the research scholar before applying any test. So we should keep it in our mind, then only we can apply the test according to our nature of our studies. And I have some examples, I will go through that. Here, see the example 2. Here the study is carried out whether the average number of housing loan per month issued by the bank per month, bank A is more than bank B. Actually, there are I have collected the data from bank A and bank B regarding about the housing loan issued by the particular banks through, in particular month. This is my, this is the data what I have collected. And what is my aim is whether the housing loan issued by bank A and bank B have any significant difference. Is it any difference between bank A and bank B? So this is the my aim. I'm going to find out with the help of my analysis whether it's having difference or not. So this is my aim. I'm going to verify these objectives with the help of this sample t-test. And for this purpose, I have framed the null hypothesis and alternate hypothesis. And it shows that average number of housing loan issued by bank A and bank B are equal. We used to frame null hypothesis like that, isn't it? There is no significant, there is no significant difference. And the second one alternative, there is the average number of housing loan issued by bank A and B is not equal. So I framed and I have collected data also. So throughout the month, I have collected the data. Number of housing loan issued by the bank A I have, and number of housing loan issued by the bank B also I am having. And before that, I should keep it in mind, the bank is the qualitative variable, isn't it? In SPSS analysis, or we can say that in statistical analysis, you can't omit the qualitative variable as it is. We should also give importance to qualitative variables. So here, the independent sample t-test, we are giving importance to qualitative variable also. So qualitative variable should be quantified. In SPSS, the qualitative variable should be quantified. How it will be quantified? Here, I have given the code for bank A, and I have given the code for, code 1 for bank A and code 2 for bank B. This code is only for identical purpose, identification purpose, not for any other calculation. If you are calculating, adding, subtracting, multiplication, division, means it won't give the meaningful result. I'm just giving the code 1 and code 2. It represents the bank A and bank B. That means that I just quantified the qualitative variable. I just quantified the qualitative variable. That's all. So, yes. So bank A and bank B, I have coded that. And let me explain how it will be applicable, how we can apply in SPSS. Okay. Just a minute. Yeah, this is my SPSS window. Already ma'am discussed in the last session. And the SPSS window is having two windows. Two sub windows like data view and variable views. First, we should start with variable view. And this variable is having a number of elements like name, type, width, decimal, label, something. Here we have to coding our variables. We should coding our variable first. Then only we can enter the data in the data view. So here I am enter the housing loan. Here I enter the housing loan. Yes, housing loan issued by bank A and bank B. Actually, this data, that housing loan issued by bank A and bank B is a continuous data. Ma'am already told that yesterday classes. It's a continuous data and it can be measured with the help of interval scale or ratio scale. Normally in SPSS, the scale, only the scale is the, they're showing. The scale included that both interval and ratio. Okay, the scale consists of what we can say, both interval scale and ratio scale. So I have collected the data. It's a continuous data. So I have to given the name of, the measurement is scale. Then I have give the, code the bank also. Here I have labeled as bank, and here I have given the values only for identification purpose. So bank A denoted by 1 and bank B denoted by 2. So what I have did, so the qualitative variable also quantified with the help of these coded variables. And this is the continuous variables. Then I have entered the data. So this is housing loan issued by the bank A and B. We should enter the data in column wise, not with row wise. Okay. We should always enter our data, the column wise data only, not a row wise data. So I have entered both, both bank issued by the housing loan. Then another column shows that 1111 shows that bank A, and another 222 shows that bank B. So after entering our data, you just go to analyze, compare mean, go to independent sample t-test. Here, the test variable, what we are going to test, housing loan issued by bank A and bank B. So we should transfer these variables into right-hand side box. Then what is the grouping variable here? The bank A and bank B, and we should transfer here. After transfer here, we have to define the groups. Here, how I identified the groups, bank A is called 1 and bank B is called 2, and give continue. And here option button is there, options button is there. Here the option is called as a confidence interval percentage, or we can say that significance level. So normally in social science, we used to say 1% level of significance, 5%, 10%, 15%. It is according to your researcher convenience, researcher's convenience. Okay. Actually, in SPSS, the default significant level is 95%. Suppose you want to increase means, I mean that 90% also you can able to put that. It's your own. I mean that it's own. I mean, so it's your own thoughts. So normally it shows that 95%. So you can, in social science research, you can go up to 30%. There is no problem. Actually, now so many researcher doesn't understand about what is the significance level. What is significance level? I will explain and then I will continue my speech as well. Actually, significance is before we starting about the significance, statistics. Well, let's see the meaning of statistics. Statistics will not give the accurate result. Statistics can able to give only the appropriate result or approximate result. That means that there is a chances of error in statistics. There is a chances of error in statistics. Here, I am giving 95. 95 means 5% chances of error in my work. I am allowing that only 5% of chances of error. So with the help of 5% of chances of error, I am doing this work. Suppose I am very confident means I can make it as 99%. That means that 1% of chances of error. Sometimes I am not very confident about this variables means I can go for 90%. I mean that 5%, 10%, 15% I can go. So normally the default value is 95% and give continue. And bootstrap we don't want to discuss now, and give OK. The result will be produced by the another window, output window. Here you can able to identify the two types of tables. The first one shows that the group statistics. So group statistics, we can able to identify the bank A issued 10 numbers of loan and bank B also issued 10 numbers of loan. And the mean value of loans also they have given in lakhs or in lakhs. And the standard deviation. Standard deviation means the mean value, the deviation from the mean value from another mean value, and standard error. So this is like a group statistics. And then another one is independent sample t-test. Yes, this is the independent sample t-test. Here we should be note this 0.602 at the degrees of freedom of 17.652. So this is what we can say at 5% level, whether it is accepted or rejected. We are going to test at 5% level whether it is possible to accept these conditions or not. Here, the decision to reject the null hypothesis. I have stated here, I have written here the decision to reject the null hypothesis. Suppose our p-value is less than or equal to 0.05, we can reject the null hypothesis. But what we have actually got, now, 0.602. This is, if you are comparing with this 5% level of significance, it is more. That means that we cannot able to reject the null hypothesis. We have to accept the null hypothesis. Here I have stated here, from the output 15.4, sorry, the t-value is 0.53 with the degrees of freedom and p-value is 0.602. And it is more than 0.05. So we accept the null hypothesis at the 5% level of significance. Therefore, it can be concluded that the average number of housing loan issued by Bank A and Bank B is equal. There is no significant difference between Bank A and Bank B in regarding issuing of housing. So I can able to verify the objectives. I have verified my objectives. I can able to draw a suggestion also, and I have draw a conclusion also. So both bank performance relating to issuing the housing loans are same. There is no difference. I can able to conclude from this work. And one more example also I'm having. This is the another example. Yeah. Actually, a statistical test is conducted to compare the result of undergraduate students of two colleges, X and Y. Same. The last examples, we have seen the housing loan issued by the bank. Here, the statistical test conducted in college A and college B. Sorry, college X and college Y. We are just going to compare. So which college has performed well in the particular things. And for this purpose also, I have framed the hypothesis like the average mark of the students of two colleges are equal, and null hypothesis is not equal. And here the variable, I have coded the variable. How I coded the variable? Here college is coded as 1, and another, college X is coded as 1, and college Y is coded as 2. This is the form of the data, how we can input in the SPSS. Then, as usual, same format, go to independent sample t-test, transfer the test variable into test variable box, and transfer the grouping variable into grouping variable box, and define the groups also 1 and 2, and click OK means you will get the result. And here I got the result. Here, college X, number of statistical test collected, number of participants is 16. From college Y, number of participants is 18. And here it shows that mean value, and here it shows the standard deviation value, and here it shows the t-test value. Here we can say that 0.847. This is also higher than the level of significance, that is less than 0.05. So what we can say here also, we can reject we can accept the null hypothesis and reject the alternative hypothesis at 5% level of significance. And it can be concluded that average mark of the students of two colleges are equal only. There is no significant differences between two colleges regarding the statistical test. So this is the inference I can given in my analysis. Participants, any doubt? Participants, any doubt regarding about this test?
No, sir.
Thank you. I hope you made me understand that what is t-test, or where we can apply, how we can apply, how we can code out the variable, how we can quantify the variable, quantify the qualitative variable, isn't it? Clear? Any doubt?
Yeah.
Thank you. Shall we go for another test? I mean that dependent sample t-test.
Yeah, sure, sir. Sure.
Yeah. Yeah, this is another test. It's called a Pert sample t-test. This is also most frequently used by our researchers for doing their research work. I have given what is a Pert sample or what is a dependent sample t-test also I have given. And yeah. And it's also having some assumptions. It's also having some assumption like the difference between means are normally distributed. All the t-tests are based upon the, is based on parametric test. So all the assumptions are, all the tests are having the normally distributed assumptions. And in dependent sample t-test, we can use the interval scale data or ordinal scale data with many alternatives we can use. And the data is not skewed. That means that the data should be normally distributed. If it is normally distributed, the result will not give correct conclusions. Okay. And here also the application area is much better, much more. Social science, management, zoology, English teaching, even physical education. Actually, dependent sample t-test is simply we can say that before and after. If I'm giving, Say for example, the performance of the staff before giving the training program, I may be noted. And after that, after giving the training program, the data were collected. So before, how their performance, after giving the training program, how they are reacting and how their performance. So this is before and after test. Mostly now, so much of resources are using the per sample t-test, and even not even in social science, management studies, zoology. If you are looking into the zoology, before using the drug, what is the sugar level? After using the drug, what is the sugar level? Whether the drug is have any significant contribution to reduce the sugar level or not. So zoology people are using, and English language teaching people are also using, and physical education people particularly. We can say that even physically education, before giving the training to the particular student, that means that 100-meter athlete, before giving training to the athlete, what is the performance of the athlete? Then after giving the after giving the training program to the athlete, what is the performance? We can measure whether the training is giving any fruitful result or not. So in all those fields, we can apply the per sample t-test. And here, yes, I have given some example how we can work this. Yes, a pharmaceutical company is the process of introducing the new drug. Yeah, that the particular company is going to introduce the new drug, and whether the drug is effectively drug can be effectively be used in reducing the sugar level. So they want to test that. They want to test that whether the drug is effective or not. For this purpose, I have collected the data. Here, the sugar level of the respondents before using the drug, and here sugar level of the respondent after using the drug. So I have collected some 10 respondents before and after, and for this purpose, I have framed the hypothesis like the null hypothesis state that there is no significant difference in sugar level before and after using the drug, and alternative hypothesis was that there is a significant difference between the sugar level. Sorry, here I did a mistake. So with this hypothesis, I am going to work out how we can work out in the SPSS. Yes, here the variable view. First, I have to code the variable here. Here I have coded the variable sugar level before using the drug, and another data sugar level after using the drug. Both are continuous variable. That's why I have given the scale is called measure. I mean that scale it belongs to ratio scale. That's why I have given scale. Then go to data view, go to analyze, compare mean, and here we are having per sample t-test, and here we have to choose both the tests simultaneously and transfer into the per variable box. And here also option button is there. Here also you can shows it shows that 95%. And if you are not interested with the 95%, you can give 99%. That means that 99%, I am confident that this result is accurate. Just implied like that only. So default is 95. We will go with 95. Then give OK. Yeah. Actually, the dependent per sample t-test to produce the 3 tables. The first table shows that the sugar level before using the drug, the mean value, numbers, standard deviation, and standard error. And the second table shows that correlations, whether any correlations between before and after using the drugs. Here it shows the negative correlations. Whether it's positive correlation means we can say that it's have some effect on reducing the sugar level, but here it's showing negative. This is the first step for testing our per sample t-test. It's not satisfied, then we will go for the per sample t-test. Here, the per sample t-test. Yeah. Yeah, the Pert sample t-test value is 1.302 and with the degrees of freedom of 9 and sig value of 0.225. It's also greater than 0.05. So we can conclude that we accept the null hypothesis and reject the alternate hypothesis at 5% level of significance. And therefore, it can be concluded that drug has no effect in reducing the sugar level. So this is the conclusion I can able to draw on from this analysis. And I have also verified my objectives also with the help of this Pert sample t-test. And one more example is also I'm having. Yeah. The another example is the HR manager of the company wants to compare the performance of two sales executive. I have already told you, they can able to compare the two group of populations. So இது எப்படி பண்ணிருக்காங்க பாருங்க. Let's see that average sales of last 6 weeks before and after were trained. So I have collected the data before giving the training program. I have collected the average sales of salesman A and salesman B. And after giving the training program, I have collected the data about the salesman A and salesman B. So after that, I am going to test whether the training program is effective or not. So I have framed the hypothesis like there is no significant difference between the and the alternative hypothesis there is a significant difference. And this is the data I have inputted in SPSS. Go to compare means, click Pert sample t-test, transfer the value into Pert variables and give OK. It produces the result. Here, there is no negative correlation. There is a correlation 0.624. There is a moderate correlation between before and after training program. And here the sig value is not significantly different at 5% level. Anyway, you can't able to give any conclusion with the help of this result. We should go for the another thing, the Pert sample t-test important result. Here it shows that the t-value is 0.165. It's very low. And degrees of freedom is also 5. And here the sig value is 0.875. Comparatively, it is greater than 0.05 according to the level of significance. So here also we are going to reject the null hypothesis and accepting the alternate. We accept the null hypothesis and rejecting the alternate hypothesis and says that the average sales by two sales executives are equal before and after giving the training program. That implied that the training program is not effective. So this is a Pert sample t-test. Just I want to show to you. Any doubt regarding about the Pert sample t-test? Participants?
No, sir. No, sir. No,
I
sir.
clearly
We could
understand, sir.
understand clearly, sir.
Clearly understand. Thank you. Any other queries? Any other doubts? Any other clarification? Shall we go for one-way ANOVA? Yeah. Actually, if you are going to compare only two variables, or if you are going to compare only two population, means we will go for t-test. Suppose if you are going to compare more than two variable, means we should go for ANOVA test. We should go for ANOVA family. If you are having more than two variables or two group of populations, more than two group of population, we may go for one-way ANOVA or we may go for two-way ANOVA. Sometimes some research or some nature of studies, factorial ANOVA can be used, and sometimes ANOCOVA may be used, sometimes MANOVA may be used, sometimes MONOCOVA may be used. So these are the tests come under the ANOVA family. One-way ANOVA, two-way ANOVA, factorial ANOVA, ANOCOVA, MANOVA, MONOCOVA. Nearly 6 tests are available. But now in this session, we are going to discuss only the two tests, one-way ANOVA and two-way ANOVA. Okay. Let's see how it will be. Yeah. This is the meaning. I have already just now I have spoke about, so I just now I have said about this meaning of one-way ANOVA. And origin of ANOVA, like something I have given. It may be used. It may be useful for your at the time of writing your research work. It also having some assumptions. So many assumptions it's having. And applications area, it also applied in social science, management studies, English language teaching, physical education, agriculture, medical science. Yes, So many medical science. I mean, even doctors are also using this ANOVA test. I will explain where it will be used, how it will be used, why it will be used with the help of some examples. Okay. See, I have data. The same thing, the pharmaceutical company is interested comparing the average sales of its four salesmen, A, B, C, and D. So up to T test, we are comparing only the two salesmen or two group of people. And here we are going to compare four salesmen at a time. Either what we are going to, what we are going to test the weekly sales by the salesman in hundreds of units. So here the variable is more than 2. So I have to go for ANOVA. I should not go to t-test thing. And here I have collected data. Yeah. Here the variable sales is the dependent variable and salesman is the independent variable. So clearly identified. So which one is dependent variable and which one is independent variable? And here I have to code the independent variable must. Here the coding the independent variable is very must. Because salesman X is coded as 1, salesman Y is coded as 2, salesman Z is coded as 3, and salesman W is coded as 4. I am explained with the help of data. Yeah. So here variable in the first row, I have, in the first row, I have mentioned the sales in number of units. That means the total number of sales. It's a continuous variable. That's why I have measured with the help of scales. And another thing, salesman. Here I have coded the salesman. Salesman X is coded by 1, 2, 3, and 4, like that. So we should be coded and we should give nominal scale. Why should we give nominal measurement? Because only for identification purpose. We should not able to, or we should not do any calculation with the help of this number. Okay, it's just only for identification purpose. Best example is we used to give the roll number to our students, isn't it? If you're going to first year classes, we used to give the roll number. Roll number 1 is maybe Aruna. Roll number 2 maybe Bhuwana. So like that, in the first year, if you are going and asking who is roll number 1, means Aruna will be stand up. But in go to second year class, who is roll number 1 means Aruna will not be stand up. Maybe Amuda may be stand up. So here the one is identification purpose only, not for any other purpose. That's why I given the nominal scale measurement. Then I have entered the data view. I will enter the data into the data view. So clear. Go to analyze, compare mean. Here one way ANOVA option is there. Click. So what we are going to test? Sales in number of units we are going to test. And here the salesman is the factor, or we can call this independent variable. Here option is there. You don't want to go now. I will explain these options in two-way ANOVA and just give OK. It produced the result. I will show the result in Word file. Yeah, it produced the result. What it produced? Degrees of sum of square, degrees of freedom, mean square, F-test value, and SID value. Here also 5% level of confidence. The default value given, programmed in SPSS, 95% confidence level. Here we have got the value of 0.762 and it is greater than significance level. So we are accepting the null hypothesis and rejecting the alternative hypothesis and concluded that average sales by the salesman do not differ significantly. So this is very simple, like t-test. Like t-test only we can able to compare at the time two group of population. Here more than 2 group of population we can able to compare. But the interpretation interpretation is same for t-test. Okay, clear. I'm going to explain another examples in ANOVA. Yeah. So here the LED bulb company manager. want to test the different brand like A, B, C. There are 3 different brands of LED bulbs are available. I'm going to test the lifespan of the each and every LED bulb from the particular brand. So this is the way I have loaded the data in the SPSS view. Here brand, here you can see that brand is the qualitative variable. So I just giving coded, I mean that qualitative variable I have identified as a quantitative variable. For that purpose, brand A is coded as 1, brand B is coded as 2, and brand C is coded as 3. So I have categorized the data, or I can say that I can categorize the data. Then what we will do, we input the data like this into SPSS, go to compare means, one-way ANOVA, transfer the dependent list like lifetime, and brand name is in factor, and give OK. The result will be produced. Here also, meeting. So here also we can able to identify that there is no significant differences. So we accept the null hypothesis and reject the alternative hypothesis here. And we can conclude that the lifespan of the different brands of LED bulbs are equal only. It's not different, it's equal only. So this is the conclusion we drawn from this one-way ANOVA. Any doubt, participants?
No, sir.
No doubts regarding about one-way ANOVA? Shall we go for
No, sir. No, sir.
Shall we go for two-way ANOVA?
Yes, sir.
Sure, sir.
Yes, sir.
Okay. Yeah, two-way ANOVA. Here we are having multiple number of variables like 2 into 3 matrix, or we can say that 3 into 2 matrix. And this ANOVA is also having some basic assumption. It should also having the continuous variable. The distribution should be normally distributed, and there is no significant, there is no outliers. So some of the basic assumption also is there. And the applications area also much more. In consumer behavior analysis, marketing management, social science, English teaching, biological science, physical education, mostly all the field we can use the two-way ANOVA. So let me explain how we can apply the two-way ANOVA in SPSS with the help of some of the examples. First, I start with the second one. Here, I have some data regarding about washing powder. Actually, I have collected data from 3 types of washing powder: brand A, brand B, and brand C. Just I want to test the effectiveness of, effect of whiteness. What will be the whiteness if you are using the brand A, and if you are using the brand B, and if you are using the brand C. And at the same time, I'm going to introduce the another variable like if you are using the brand A, B, C in normal water means what will be the effect? If you are using in the hot water means what will be the effect? And if you are using in the cold water, what will be the effect? So this is called as two-way ANOVA. We are applying, or we are applying number of variables at a single, single calculations. And here I have framed the hypothesis also. Here you must be noted that how I have coded the variable. Here the dependent variable is whiteness of cloth. We know that. Here the independent variable, we are having 2 types of independent variable here. One is washing powder. Another one is water quality. Here washing powder A is coded as 1, B is coded as 2, and C is coded as 3. And at the same time, the normal water is coded as 1, hot water is coded as 2, and cold water is coded as 3. I hope that the problem what we are going to do, you may understand about this problem. Is it clear? So we are going to test the whiteness of cloth based upon the different types of brand of washing powder, and at the same time different conditions, nature of water, normal water, hot water, and cold water. So this is my task, or this is my objective, is to verify whether the washing powder can significantly give impact on whiteness of cloth in different types of water conditions. So this is my data. I have in SPSS also. Yes. Here, I have coded the value variables like washing powder. Yeah. So washing powder. Here, washing powder A is coded as 1, B2, C3. Just for identification purpose, that's why I have given nominal scale. And nature of water. Nature of water also I have given 1, 2, 3. Just for identification purpose, that's why I have given nominal scale. And I got the result also. I mean that the performance. So it's a continuous variable. That's why I have given the ratio scale. Clear? Then this is the data view. So this is the washing powder. Coded, A is coded as 1, B is coded as 2, and C is coded as 3. And this is the water, nature of water, cold water, hot water, and normal water. So in this way only you have to input the data in your SPSS. Okay, this is the percentage of whiteness, 68%, 62%. So this is a continuous scale. That's why I have given in that. Now go to analyze, general linear model, univariate. Here what we are going to test, the percentage of whiteness. And what is here? Fixed factors, both washing powder and the nature of water. You just click and transfer the values. And here you just click the model. Actually, this is the full factorial model, so don't go for customs. Allow it to continue. I mean, give continue. Contrast is default one, give that. And here we are having one more option. It's called post-quark test. Here it's called post-quark test. I will explain why we are using the post-quark test. You just transfer the value into the post-quark test box and click the dir key, or you can give the Duncan. Most of the science people are using Duncan. Social science people are using the dir key test. Give continue, and the options here. I mean that what we are going to, I mean display the mean value of all those things. And give continue. Yeah. At the end, click OK. It produced the result. Here you can able to identify what are the coded variable involved in our analysis. Here washing powder 1, 2, 3. I mean washing powder A, B, C is coded as 1, 2, 3, and water quality is coded as 1, 2, 3 here. This is the test between subject effect given produced by the two-way ANOVA table. Here you can able to identify that washing powder have a significant effect. That means that the significant level is 0.03 and it is less than 0.05. So here we are rejecting the null hypothesis and accepting that the washing powder has significant effect on whiteness of cloth. And nature of waters also we have discussed now. We have input the data now. So that also shows that there is a significant difference between nature of water. That means that normal water, cold water, and hot water. And if you are using and if you are putting your cloth in cold water, the result will be different. Hot water means the result will be different. And washing powder also the result will be different. So what I am trying to say that is I have got a significant result here. And I can say that both washing powder also having a significant impact, and at the same time, the nature of water also have a significant impact on whiteness. So this is the things I have derived from this table. Then I will go for another one. Here, we can say that this one is multiple comparison. If you are comparing washing powder A with B and C, if you are comparing the washing powder A with B and C, what will be the significant result? If you are comparing means, this is called multiple comparison table. If you are comparing, the result shows that if you are comparing the washing powder A with B and C, only B is the very significant. C is not significant. B is significant with A, but C is not significant here. And if you are comparing the B washing powder B with A and C, here A is only the A is correlated with B or significant with B, but C is not significant with B. So likewise, the multiple comparison tables also produced by the two-way ANOVA, and it will be more useful at the time of interpreting the result. And I have also applied the post-quark test, isn't it? The post-quark test. Normally in south side, most of the people are not using the post-quark test result. The post-quark test result shows that, before I explain the post-quark test result, I am just showing the test between subject effect. Here it shows that there is a significant difference between the variables, but it doesn't tell about it which variable is highly significant and which is low and which is medium. It won't give that result. It only said that there are a significant difference between washing powders and at the same time nature of water. It won't produce any other result. But if you are giving the option post-quark, it shows that which powder is having more good and which is not good. Here the homogeneous subset explained the which is superior and which is good and which is least and which is medium. Here we can be able to identify that there is a high value got by washing powder A and washing powder C. High mean value of 68.4 and here 65.80. So it shows that this is the washing powder A brand A is a first one, high quality, and brand C is the second one, and brand B is the third one. So this is the result produced by the Durkee. Same thing, only Duncan also produced. There is no much differences. And here, related about the water is also having some difference. If you are using the powder in hot water, in cold water having the high mean value. If you are using that powder in normal water, the whiteness is very less. Suppose if you are using that powder in hot water or in cold water, it produced more good result. That means that 69% mean value, and hot water 65.8 mean value. So this is all formed as one group. That means that using in cold water is more effective, and hot water is also maximum level of effective, and normal water is very less effective. So with the help of this, we can able to identify that there is a significant difference between the variable and which variables is having more influences on the particular things, whether in hot water or normal water, or whether it's the brand A or whether it's the brand B. So in this way, the two-way ANOVA table, the two-way analysis, two-way ANOVA will helpful for the researcher for doing our research work. And I have one more examples also. It's regarding about what I can say. Yes. An experiment is carried out to test whether different types of drugs like ABC have different effects on males and females. So here we are having three drugs, two groups of population, male and female. So this also a qualitative variable, and this is also a qualitative variable. We should be identified with the quantitative. Okay. So I have collected the data. So these are the hypotheses I have framed to test my data. Here we must be noted that the dependent variable is percentage cured. Here the independent variable is drug and gender. We have two, isn't it? So coded variable, what I did, male is coded as 1, female is coded as 2. And drug A is coded as 1, drug B is coded as 2. And drug C is coded as 3. So in this way, we have to input the data in our SPSS. And after that, we should go to analyze. general linear model, click univariate, then transfer the data into the dependent variable, the another fixed factor into the fixed variable, and give the post-quack test option, transfer that, give Durkee options, and here you transfer the overall mean value and give OK, it produces the result. So if you are looking into the result, the gender, that means that male and female. Here, the male and females have doesn't effect. I mean, drug. There is no effects of drug among the group of male and female. Among the group of male and female, and at the same time, sorry, gender. And at gender is having 0.09. Here the 0.09, I can accept that point. If it is less than 0.05, it is 5% level of significance. Here I can coded that. What I can say, that means my level of significance is 10. Here I am accepting the, I am accepting the alternative hypothesis. So I can change that level of significance here. From 5% is 10%. I should be coded that like this, and I can set that shows significance level of 10% level of significance. So here the 10% of level of significance, the drug has more impact on gender. And here the drug value, there is no thing. And if you are comparing the gender and the drug with a particular group of people, it also giving the fruitful result. Yes, at 10% level, I can able to accept the alternative hypothesis. I can reject the what I can say, null hypothesis. So this is the thing I have given here. And here also I have given multiple comparison. If you are comparing the drug A with the drug B and C, what will be the significance level? And if you are comparing the drug P with the A and C with the A and B. So this is a multiple comparison result. And this is the post-hoc test result. And it shows that there is no significant effect of drugs of A, B, C, because all the mean values are more or less same. So that's why there is no another subset for these drugs. So what I am trying to conclude here is there is no impact of drugs to cure the particular problems. That means that there is no much difference between these three drugs. All gives the same result of curing these diseases. And it can be concluded that all drugs have same effect in curing the diseases. So this is the interpretation I can draw on from my result. So in this way, you can apply the two-way ANOVA in your studies. So depending upon the nature of studies, nature of problem, nature of variable, the interpretation and other thing will be changes. But the procedure, how we are going to apply is the same. Participants, any doubt two-way ANOVA regarding the two-way ANOVA? Any doubt?
Good evening, sir. I would like to know the path. I want to note the way to analyze the data. Sir. That is how to
analyze step by step.
The path, yes, sir.
Yes.
Yes, sir.
So this is the thing. I have to go to analyze, go to general linear model, univariate. Here what I am going to test is percentage of whiteness. So I should transfer this variable into dependent variable box. And here the fixed factor is brand of washing powder and the nature of water here. So I just transfer these two variables into fixed factors. Then I go to model. There are two types of models are there, factorial, full factorial and customs model. For this data, we should follow the full factorial. So I just give continue. Contrast, we don't want to give contrast, just give. Plot, we don't want to give. Plot, no need. And go for post-quack. I need a post-quack for two things. I mean, two variables, isn't it? I just click Durkee. Durkee is mostly used by the social science people Duncan is used by the science people. Okay, and give continue. And here one more option is there. If you want to know the overall mean washing powder, brand name of the washing powder mean, water quality mean, means you need to show the result in your project mean, you just click that and transfer and do OK. And finally, if you are giving OK, means the result will be produced by the SPSS. So this is the way to conduct the two-way ANOVA.
Thank you, sir.
Thank you. So any doubt regarding about the two-way ANOVA?
Sir, is it essential to do post-hoc in every test, sir?
If you are doing the post-hoc test, means it will be more clear which one will be the superior, which one will be the inferior, or which one will be the most influencing factor, and which one will be the least influencing factors. It's not necessary. And if you are doing means your examiner or your guide maybe understand that you maybe will know about the tools, and it also the tools will also that the post-hoc test also will give the very good result. You can apply. It depends upon the researcher only. There is no conditions for applying the post-hoc test. If you are upgrading your test means you just go for post-hoc. Otherwise, you stop with two-way ANOVA. No props.
Thank you, sir.
Thank you.
Sir, I have one doubt, sir.
Tell me, ma'am.
You have used factorial some variables, sir. Where I use the custom variable.
Yeah, customs model. The customs model will be applicable in some other nature, some other time. Like that, if I'm having all qualitative variables, if I'm having the variables, all the variables are having in qualitative nature, I can go for customs model. Or we can say that I don't want the full factorial model, I will go for customs model, means we can go. The same data we can use the customs model also. I will explain. Same data we can use for customs model also. The customs model is something different. Nothing. Here I'm going to transfer the washing powder and the nature of water. Other things are all same. Here in customs model we can give. We have one more chance to give. What? Which one? Washing powder and nature of water. Factors and covariates. So this is a difference between factorial and customs model. It depends upon the nature of data, nature of studies. But mostly we don't want to go for customs model. Full factorial is enough for doing our research work. Sometimes we can't have any other chance. The variable is like that, means we can go for a customs model.
Thank you, sir.
Any doubt regarding participants?
Excuse me, sir.
Yes, ma'am.
So regarding 2K and Duncan, is the basic concept the same, so the underlying logic, while 2K is for social science and Duncan for sciences, is the basic...
No, ma'am, not like that. All the test results are producing the same one. But
Okay.
mostly, science people mostly used Duncan test. They are most likely the Duncan. But social science people used to use the Durkee. Actually, these tests are common. All the tests are producing the same result. There is no much difference between the output produced by the test. All the tests are producing the same result, but different types of tests are available in SPSS. You can choose anything.
Okay, thank you, sir.
Durkee is normally used by the social science research, as by my knowledge. And Duncan may be used by the science people, zoology, biologist people.
Thank you, sir.
Thank you, ma'am. So any other? Just 2 minutes break. I will come back. Okay. Please don't left from the webinar. That meeting. Just 2 minutes break.
Sure, sir. Sure, sir.
மேம் சார் சாட் பாக்ஸில் போட்டிருக்காங்களா, கொஸ்டின் கேட்டாங்களா சார்? சாட் பாக்ஸில் போட்டிருக்காங்களா? Actually, one question asked by the Dr. K. Palanichami, how we can feed the data into SPSS, whether I can copy the data from Word file or I can copy the data from Excel file. Both are possible, ma'am. You can copy it and paste it here. Here, the main thing is you have to code the variables. You can copy the data from anywhere, but from Word file or Excel. You can copy the data and paste it here. At one time itself, you can copy all those data. And here the problem is we have to code at that. So what type of variable I have entered and how I'm going to measure that particular variable. So that is the most important in SPSS. Entering the data is not a big business, but we have to code at that. How we can going to code our data. For this, we must know about what type of variable we are having and how we are going to measure that variable. That means that what type of, which scale can be used to measure the particular variable, and whether it's a qualitative variable or quantitative variable, how I can identify it, or how I can name it into quantitative. So this thing you must be known, ma'am. That is the basic things before entering and before coding our data. Ma'am, sir, are you satisfied? Sorry, are you satisfied, sir? Thank you, sir. Thank you, sir. So any other questions? Thank you.
Clearly understand, sir.
Thank you, ma'am. So shall we go for one more chi-square test?
Sure, sir. Sure, sir.
And this test also mostly used by researchers, isn't it? Maximum, I went through so much number of thesis work, and mostly all the researchers are very like to use the chi-square test in their research work. Number of scholars approached me, sir, there is any possibility to apply chi-square test? There is any possibility to apply to Way Anova? So this is a very famous test among the research scholars at the time of doing the research. Chi-square test, this is also not much more difference between two-way ANOVA and the chi-square test. So anyway, we will go how it will be calculate in which situations we can apply the test, how we can apply, how we can interpret, and how it will produce, how it produce the result also we can see. And And applications area, it also applicable in all those areas: social science, biological science, language teaching, medical science. It's like all the tests here also we have to frame the hypothesis, both null and alternative hypothesis. And the framing the hypothesis is same. Null hypothesis implied there is no significant difference, and alternate hypothesis shows that there is a significant difference. And here I have given some of the examples. Let me start with the second one. Yeah. Here, I have collected the data regarding about the performance of the firm based on the locations. So there is an entrepreneur, and here that particular entrepreneur having the firm in different location, like rural, semi-urban, urban. So in 3 places, they are running the particular entrepreneur is running the firm, and he want to measure the performance on the basis of loss, break even, and profit. And you might be clearly understand about what do you mean by break even point. So break even point is no profit, no loss region, and if you are below the break even point, it's called a loss. If you are more than the break even point, it will produce the profit. So this place, the entrepreneur want to check the performance of the firms on the basis of loss, break even, profit, and on the basis of location. That means that locality, urban, whether urban or semi-urban, or we can say that rural. So this is the thing I'm going to check with the help of this data. I have collected the data, location. Here I have coded that urban is coded as 1, rural is coded as 2, and semi-urban is coded as 3. Simple. And here the another variable like loss is coded as 1, break even is coded as 2, and profit is coded as 3. Simple. And here I have noted that performance also. Here I have noted the performance also. Okay. I will explain. Go to analyze, descriptive statistics. Go to descriptive. Sorry. Analyze, descriptive statistics, cross tabs. You just go and give the label. Go to statistics, click chi-square, click continue, row OK. And here one more option is there in chi-square. There is a cluster bar chart also you can get from output SPSS. Click OK. So we got the result. So here the location, urban, rural, semi-urban, loss, break even, profit, and regional. And here we got the chi-square value. Here also we have got 0.827. That is not less than 0.05. It is more than 0.05. So we can reject the we can reject the alternate hypothesis and accept the what we can say null hypothesis. Here I can source that A2 it is more than that. So the null hypothesis and concluded that the performance of the firm is independent of the locations. So what the derivation, what the outcome I have got from that result analysis is the performance of the firm is independent of the locations. So this is the result I have drawn with the help of the SPSS output. And based upon that, one more example is also I am having. Here I have another examples like an educational institute interested to test that there is a relationship between the educational background and chances of getting job with good salary package. So educational background and chances of getting jobs. Here the educational background, like those who are studying economics is coded as 1, those who are studying commerce are coded as 2, BBA coded as 3, and science is coded as 4. And here the salary package also I have given. Less than 5 lakhs is coded as 1, 5 to 9 lakhs is coded as 2, and greater than 9 lakhs is coded as 3. And this is the way I have to enter the data into SPSS. Here the educational background is coded here, and here the salary package is coded here. Here we are having salary package is also coded variable, and we should measure with ordinal scale. And then go for testing purpose. go to Analyze, Descriptive Statistics, choose Crosstabs, transfer the variable into respective box, and click chi-square test value, and it produces the result. And you can be able to clearly identify what the result we have, got. Here, the Pearson chi-square test value is 0.445, and it is also greater than 0.05. So we can conclude that the chances of getting job with good salary packages independent of educational background. So this is a small things we can interpret from the result. So that's all. Simple. Chi-square is very simple. Any doubt?
Sir, good evening.
Yes,
Uh,
ma'am.
my name is Bushra Barkati, research scholar from Delhi University, Department of Social Work. So, wanted to know one thing. Like you have mentioned in chi-square, both the ones are the categorical scale.
Yes, ma'am.
Despite of being the income being a variable which can be measured in terms of numbers, numeric. So,
Mm.
sir, why it's such so? Because both the data has been categorical, and you have mentioned also in the same. So, why so?
Not ma'am. My example is like that. We can use that not coded variable also. We can code. You can use that. Continuous variable also you can apply in chi-square test. There is no need for categorical variable. Continuous variable also we can apply it in chi-square, ma'am.
Okay, okay. So there are chances that we can go with one continuous and one categorical and one scale.
Yes, ma'am. It's more possibility.
Okay, sir.
Thank you, ma'am.
Thank you, sir.
Excuse me, sir.
Yes, ma'am.
In the output table, there is something like asymptotic significance. Can you please explain that, sir?
Which one, ma'am? Output table?
Asymptotic something. Asymptotic significance. Yes, sir. Chi-square.
This one.
Yes, sir.
This is significance value.
What is sir? Asymptotic.
Here in chi-square, we are using observed and expected, like the two things we used to use. Isn't it?
Yes, sir.
In manually, you are doing calculation in observed value, expected value, assumed value, like something we are using. Yeah. So likewise in SPSS, it produces the result as sums. And it shows that I will show that in in SPSS. Yeah. I'm not clearly about this, the meaning of ASYMP asump, but I know the meaning of the SIG value. SIG is the significant value. I'm not more clear about this one, ma'am. I will refer and I will tell you tomorrow. Okay.
Thank you, sir.
Sorry.
Not at all, sir. Thank you, sir.
Sir, good evening, sir.
Good evening, sir.
Sir, I am from Chikana Government Arts College, Tirupur.
Okay, sir.
Sir, how to find dependent variable or independent variable, sir, in chi-square test?
Sir, actually, the dependent and independent variables have to find out by the researcher only with the help of reviewing number of articles. At the time of reading the articles, you should be note down what type of variable they have taken for their analysis. In every article, they have given clearly what type of variable they have taken for dependent variable and what type of variable they have taken for independent variable. So this first step, that the first knowledge of the researcher for all those things, we got only from our literature. We got only from articles. If you are go through the articles again and again, number of articles, and you should be taken note it out. So in this analysis, why they have taken this variable as the dependent variable. It should be based upon the nature of study, And the researcher must understand what is dependent, what is independent for the particular analysis. So we used to call as dependent means, say for example,
Gender.
my saving is also depends upon my income.
Yes, sir. Yes, sir.
Isn't it? But here saving is the yes.
Independent variable.
Yes, that's all.
Okay, sir.
Sir, good evening, sir.
Good evening, sir.
Sir, which kind of variables can be used for which kind of test? Is there any?
Yes, I have some flow charts, sir. Flow chart I am having. Tomorrow I will shows that, sir.
Okay, sir. So, where to use dependent t-test and where to use independent t-test, chi-square, ANOVA? Is there any?
No, sir. It depends upon your studies only, sir. It depends upon fully your studies.
Okay, my studies okay, but is there any rule for this? I have to use for example, if I want to know the difference, I have to use ANOVA. If I want to know
yes,
know
sir.
the
If you are going to compare the two population, you should go for t-test.
two population or two different population.
Two different populations. You
For
can go
example,
for
if I'm looking for the sample of teachers, private school teachers and government school teachers, like that.
Super,
is it right?
Exam. Yes, sir. Correct, sir. That is called independent sample t-test. And
okay, dependent means, sir? Yeah,
dependent means the population is the same population, but before giving the training program, what will be the what was the performance?
Okay. You have told that.
Yes.
Previous and after.
Yes, sir. Yes, sir.
Right.
And why we are going for ANOVA is we are having we can able to test only two variables in t-test. If you are having more than two variables, we should go for ANOVA. We should go for one-way ANOVA. That's why I have explained the one-way ANOVA. And if you are having multiple comparison, you should just go for two-way ANOVA.
Multiple comparison. Okay.
Male
so
and
for
female.
ANOVA, for at least we should have one continuous variable. One continuous variable, no?
Yes, not necessarily. A continuous variable we should have.
Yeah.
Yes, sir.
Thank you, sir.
Thank you, sir. So any other question related about the topic what we have discussed today's session?
Yes, sir, I have.
Tell me, ma'am.
So the session was very insightful and captivating.
Thank you,
so can you just provide the summary? Like you mentioned, all the test comes under parametric, and the population should be normally distributed.
Yes, ma'am.
So can you just provide the summary in brief? Like t-test is for different when we want to measure difference in mean values of group, and paired is when dependent sample we go with before and after. So
yes,
can you provide a summary of this all in just a very very brief way? Thank you, sir.
Thank you, ma'am. Ma'am, sorry, ma'am, there is some technical problem. Can you please repeat your question?
Sir, I wanted you to please just provide a summary of all these. Like you mentioned, parametric test, we go with normal distribution.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Then
I will summarize, ma'am. I will summarize. No problems.
Yes, sir. Just a very brief, just a gist of that.
Okay, ma'am. Okay, ma'am. Okay, ma'am. So actually, there are two different types of tests are available: parametric test and non-parametric test. So parametric test, the conditions for using the parametric test is the population size must be known by the researcher. That means that the population size is finite populations. So once the population is identified, or once the population is the finite population, we can go for selecting parametric test. Suppose the population is unknown population or infinitive population, we should go for non-parametric test. So this is the first step why we are going to parametric. And in parametric, if the population is known population, we can use the different types of sampling method like stratified, strata sampling, random sampling. So with the help of that sampling method, we can collect the data, and that collected data also normally distributed. That's the basic conditions. In non-parametric, there is no need for normal distribution curve. And here in parametric, we need to say our data should be normally distributed. There is no bias in our data. It implies that there is no bias in our data. It should be the normally distributed. So if you are checking these two assumptions, we can go clearly to the parametric test. And the first test is in t-test. If you are going to compare the two group of population, you can go for independent sample t-test. That means that the two groups don't have any relations, but they are doing the same job. We are going to measure the mean value. That's all. And second one, Pert sample t-test, or we can say the dependent sample t-test. The particular group, before giving the training program, what was the performance? After giving the training program, what was the performance? So that's all over. T-test is over, man. In t-test and ANOVA, all those tests are, we are going to comparing only the mean value, nothing else. We are going to compare the mean value only. Okay. So in t-test, if you're having the two variables, you can go for t-test. If you're having more than two variables, you should go for one-way ANOVA or two-way ANOVA. Suppose if I'm having more than two variables, like salesman A, B, C, I should go for one-way ANOVA. So that is the best way to select the one-way ANOVA, best conditions. At the same time, if I'm having salesman A, B, and C, and location, rural, urban, semi-urban, and the performance. So just here I'm going to compare the salesman's locations and the performance. So in this problem, I have to go for two-way ANOVA. And in two-way ANOVA, we are having the options of post-hoc test, and we can able to identify which salesman's performance is very good compared to other salesmen's. So that post-hoc result will helpful to identify which one is good and which one is medium and which one is low. So that is called a two-way ANOVA, ma'am. And number of ANOVAs also is there. Today's we discussed this one. And chi-square test we used to normally do that. It just explain the significant difference. It's also explain the mean value difference only. And here we have a chance for continuous variable, interval variable, or we can say categorical variable. You can put any variable in chi-square and you can get the result, ma'am. So that's all. Up to now, what are all the tests we have discussed? All are based upon the mean value test. Ma'am, are you satisfied, ma'am?
Completely, sir. Thank you so much, sir, for providing such an insightful. Thank you, sir.
Thank you, ma'am. Thank you, ma'am.
Good evening, sir.
Good evening.
I want to check the normality of the data. Will you please show the path to analyze the normality of the data?
Actually, ma'am, this is for checking your data. There is a Cronch alpha test is available in SPSS, ma'am. I will tell. I will explain. I will tell that Cron alpha test is available. You just enter the data and check your data with Cron alpha. I will give notes, or I will give explain tomorrow.
Thank you, sir.
Normality of chat data, every researcher should be check the normality before every researcher must be go for a pilot survey. So from the pilot survey itself, you can able to identify whether the data is good or not, whether it's we can add something or we can remove something. This and all the things can be understand after the pilot study. So after the pilot study, we should frame the questionnaire according to the changes got it from pilot study, and collected the data. After that, we have to check the normality. For checking the normality, there is a test is available that is called as Cron-Punch alpha test. In the Cron-Punch alpha test, you just input the data what you have collected, and you have your tested means that it produced more than 0.5 or 0.67 0.6 or 0.7%. Greater than 0.6 or 0.7% means your collected data is normal and valid one, and it also shows the normal distribution. It also produces the normal distribution curve also. You can able to identify how our data is distributed. The research test is available. The test is called Cron-Punch alpha test, ma'am. I will explain tomorrow if time permit.
Hello.
Yes, sir.
Sir, I wanted to ask that in the ANOVA table, what will be the interpretation if my answer is less than 0.5 or more than 0.5 or 1?
It should not be 1. It should not be 1.
In my some of the case, I received one answer in one case only in my PhD pilot study.
Whether it is 0.001 or it is 1.
1.000.
The significant value will not become like that. Otherwise, you just make a snapshot and send it in our WhatsApp group. I will go through that and I will tell you. Okay.
Okay, not an issue. I will do that thing.
If less than 0.05 means we should reject the null hypothesis. Suppose the significant value is greater than 0.05 means we should accept the null hypothesis. Something. This is the difference.
Yeah. Thank you so much, sir.
Thank you.
Excuse me, sir.
Yes, ma'am.
So in full factorial is usually the multiple until it reaches 1. For example, 3 factorial is 3 into 2 into 1. So
yes,
full factorial, it's factorial of the dependent and independent variables.
Yes, ma'am. Yeah. Actually, in our example, we have given the two categorical variable, ma'am. That's why I have chosen the full factorial model, ma'am.
Okay.
Excuse me, sir.
Ma'am, any other?
Okay, thank you, sir.
Thank you.
Excuse me, sir. In my thesis, I listed nearly 28 strategies which is used by HR executives, sir.
Strategy.
After, yes, I used a 5-point scale.
Whether the strategies are approved by in common world?
But in the strategic management concept, there are nearly 28 strategies are available, sir.
Okay, ma'am. That I mean that if it is available means it's already checked in the world. That means that the Cron alpha test also tested and valid. The 28 statements are valid statement. You should not increase any statement and at the same time you should not delete any statement from the particular. Or you understand? 28 statements are there, isn't it?
Yes, 28 statement strategies are there, but in the particular cotton industry, most of the nearly 11 strategies are not followed. After collecting the data, I used a 5-point scale. How can I segregate? Which tool I have to use to separate the which is following a strategy, which are not following strategy? Which tool I have to use, sir?
Factor analysis is so good, ma'am. You are having number of variables, now 28 variables. So factor analysis is nothing but factor reduction technique. And if you are putting the 28 variables into factor analysis, and it will compress and then it will do correlation with them, and it will be extracted into some 5 factors or 6 factors. So from that we can able to reduce the variables into, and we will make the output into other purpose also. Factor analysis is the best tool, ma'am.
Okay, thank you, sir.
Any other question?
No, sir.
Yes, sir.
Excuse me, sir. Excuse me, sir.
Yes, ma'am.
It's the variable coded, for example, washing powder A, B, C, and other variable coding which you have done. Is it the same as dummy variable coding, sir?
Ma'am, actually, dummy variable is consist of 1 and 0 only. It's like a binary variable.
Yes, sir.
Was 0 and 1.
So this is just for the sake of analysis, we have codified the variable.
Yes, ma'am. Just for identification purpose, that's all.
Okay.
Not for any other calculation. Here, the dummy variable or the binary variable we used to use as a dependent variable in logistic regression.
Yes, sir.
Yes.
Thank you, sir.
Thank you, ma'am. So if no other question means, shall I wind up our session today? Shall I wind up our today's sessions?
Excellent explanation, sir. Thank you very much.
Thank you, ma'am. Thank you, ma'am.
Any other
Thank you,
feedback?
sir.
Thank you,
And
sir.
sir, please kindly share the flowchart you mentioned for the same.
Okay, ma'am.
Thank you, sir.
Thank you, thank you, thank you.
Thank you, sir.
Thank you, ma'am. Thank you, ma'am.
Thank you, sir. Thank you very much. Participants, regarding the feedback form, we will post it later on WhatsApp group. Thank you for the patience.
Very good evening, dear participants. So there is information for you in the WhatsApp group. The user ID today has been changed, and regarding the feedback form and the attendance form to be filled, you please enter the new user ID today and tomorrow. And this, yeah, yes, ma'am. This message is posted in the WhatsApp group regarding
Ma'am,
the
it has
user
not
ID.
been updated, ma'am. It was the same what I entered yesterday.
Okay, okay, sir.
Then
Just
it is
we'll
okay
verify,
to
and we have put it in the WhatsApp group. The user ID has been updated. The organizer has updated it. If not so, we will update it. Just now we will update it, and you have to enter the new user ID. That is what very important. And one more
okay.
information to be conveyed to all dear participants. There is a consultancy service in our college that is organized by the Sindhi Research Advocacy Forum of V.H.N.S.N.College regarding the usage of tools, SPSS tools, and any consultancy regarding research activities. So, with a minimum cost. So, we like to share with you about the consultancy services. And if there is any doubt or in the interpretation or the usage of SPSS or regarding your questionnaire, you can very well consult a team which is organized by Sindhi Research Advocacy Forum and with the help of Department of Commerce SF under the banner of V.H.N.S.N.College. So this is what we like to convey to you. And participants, if there is any doubt, you can post it in the WhatsApp group. And we look forward for the cooperation tomorrow also. Thank you, dear participants.
Thank you, ma'am.
Thank you.